Now we're going to look at what happens if we have a velocity that's time dependent. So for example, maybe we start out in a car and we're at a red light. The light turns green and we start moving. So what we want to know is what's our velocity as a function of time. So the way that we can find this out is, let's say we have somebody across from us and they're measuring our position, and they have a stopwatch and they're measuring the time. So they take measurements at time 0, at 1 second, at 2 seconds, and at 3 seconds. And they find in that time that our position is 0, 1 meter, 4 meters, and 9 meters. So right away we can see that our velocity is increasing during each time interval, right? Because we see in the first time interval, our velocity from time 0 to 1 is 1 meter per second, because we went 1 meter in 1 second. Our velocity from time 1 to time 2 is 4 meters in is 3 meters, because it's 4 meters minus 1 meter, so 3 meters in 1 second, or 3 meters per second. And our velocity between time 2 and time 3 is a difference of 5 meters in 1 second, so 5 meters per second. But again, these are just our average velocities, because we see that velocity is constantly changing the entire time. So because of that, our average velocity is changing the entire time. So to get a better picture of what's actually happening, let's draw a set of axes where now the x-axis is going to be time, and the y-axis is going to be our position x as a function of time. Okay? So if we do this, in this case, we have a parabolic curve. You'll notice by looking at it that that x of t is just t squared in the x-hat direction. That's our vector for position. So what that means is that we can split our time up into 3 sections, each of them equal distance on here, so 1 second, 2 seconds, and 3 seconds. So in the first second, we went to 1 meter. In the second second, we went to 4 meters. And in the third second, we went to 9 meters. Okay? Now let's say we call this little time interval here dx01. So the distance that we went from 0 to 1 seconds. Okay? This distance traveled would be dx12. This is the distance that we traveled between time 1 and time 2, because we're already at 1 meter at time 1. Now we went another 3 meters, so that's dx12. And then of course this distance, this height, is dx23. So these are the different distances we're going in different times. And then of course v 01 is dx01 dt. v12 is dx12 dt. And v13 or v23 is dx23 dt. Right? And so in this case, dt is always equal to 1 second. So you notice that it's always divided by the same amount of time. So now what happens if we make dt go to 0? Well, before we do that, let's say we let dt go to half. So then we'd have basically twice as many measurements now, right? We'd have x at all these new positions. Okay? So we notice what happens is each of our heights is going to get smaller because of this. So when that happens, the distance that we're traveling gets smaller and smaller, but the later distances are always bigger, right? So dx12 is always going to be bigger than dx01. And dx23 is always going to be bigger than dx12, even as we make our times get smaller and smaller. So, so when we take this limit, as the time goes to 0, that's going to give us our new velocity. So our velocity is just going to be dx as a function of t over dt. So you can imagine dt as some small number, not quite 0, but the smallest time interval we can imagine, so that our velocity is constant during that time interval. So, so for example, if we looked at our velocity, for reasons that we'll see later in the course, we can actually plot it as the slope of these lines. So then when we chop it up more, if we chop it in half, then our velocity is going to get much closer to the actual line we're measuring. We have a bunch of straight lines that are much closer to the curved line. And so again, we'll see once we get into the next book, and once we start talking about Newton's equations, we're actually going to get into calculus, and we're going to see what this actually means. But for now, this is just going to be our functional definition of velocity. So it's this small change in distance over a small change in time is going to be what velocity is.